Alright, time for another draft physics, draft science here on YouTube. Video presentation. Commenters. Well, it's just a couple of people. It's always that way, the trolliest of the trolls kind of thing. So can't take it too seriously, but clearly, people just have no capacity to follow along at all. I mean, the arguments are explicitly laid out and ignored. And so I'll have to preface this video with just going over some of the basics again, and then I will add some new stuff, and then I'll get to the moronic and insipid and silly comments that are totally not on the subject at all. So this isn't just about history. This probably needs to be turned on. That doesn't quite do it. Well, it'll have to do, as they say. I'm going to say. Anyway, this is all very tedious. You can't even, it's just to have to do all this preliminary work to do, it's like explaining. Well, somebody actually says that in the comments, can you do the 5-year-old version? It's like, no. Yeah, I can. I guess I will, but it's just, I shouldn't have to. Alright, so you have two formulas, MV, and then you have, MV, and with another V over here, divided by 2. Okay, now, one of them makes perfectly good sense, logical, sensible. Dirac, Newton, this is all you needed to understand the universe. They spelled it out pretty well. And then Leibniz, who was just a naysayer, really just spent his whole life trying to pick at other people's work, came up with this nonsense. Sort of related to the fact that, Huygens, who was a decent scientist and all that stuff, had figured out that you needed to square the velocity in the circumstance of rotational motion. So the centrifugal force kind of idea of this imaginary force that's pushing you off of something. Because it is a circle, and you're going to increase your velocity. You want to square your velocity as you go out to a wider and wider radiuses. An arc argument. This distance is a lot. Is the square essentially of this distance. This distance is twice. The distance squared, kind of argument. Anyway. All right. So we'll put the other formula back just because we should keep it in mind that this complex looking thing that doesn't make much sense versus this solid thing. So the argument is simple. The two theories say. So momentum says that I can take, let's say, we'll start with a 16-pound bowling ball going 8 miles an hour. Okay. And then you could go to a 8-pound ball. All right, and you could go 16 miles an hour. And then you could go to a 4-pound ball, and you could go 32 miles an hour. And you could just keep doing that. Just keep, changing these ratios. Now, the number's always the same in the sense that the momentum will tell you this, it'll give you the same answer for no matter how you switch these relationships. Momentum will always say, it's 16 times 8, whatever that is. Yeah, I should have used numbers where I did the calculation ahead of time. Ugh, it's just an ugly thing, isn't it? But anyway, so momentum says all of these things have the same amount of energy. You haven't changed the energy because you can't change it by switching M's and V's. You can, as long as they're reciprocal, you have the same energy. But their formula says this has 4 times as much energy, and this has twice as much energy as this. So they're and it's real energy. They're saying it in watts, in joules, in pounds. It's a real thing. This is real energy that you could somehow really recover, and it's real stuff. So you could light twice as many light bulbs with this, and you could light 4 times as many light bulbs with this. The 4-pound ball going 32 miles an hour. That's their theory. That's their equation. That's what it says. Okay, so you can just imagine. I go smaller and smaller and smaller. This number starts getting higher and higher and higher. This multiple of energy I'm making. And obviously the opposite goes the other way, right? the more mass, so if I make this what would the multiple be? Well, anyway, if I change the ratio to increase the mass and lower the velocity even more, I get negative, I'm losing energy. So, even though the momentum's still the same, their formula would say, no, you're losing energy. Okay, so the heavier I make the ball, whatever, 24 and 4, something like that. No, that's 24, so I can't go to 24. All right, so we go to 20, let's say, and 4. I have negative. Now I'm losing energy. So I make the ball heavier and slower, and now I'm losing energy. Twice as much energy, right, for that circumstance. So I lost twice as much energy. Half the energy gone, just because I made it heavier and slower. When, logically you can sort of understand it really doesn't work that way. Heavy things have lots of energy. So, the train analogy's been done over and over again, so let's not redo that. Let's not redo it. It's just so simple. Alright, so I would explain. So this gets to another theory of theirs, right? People like Leonard Susskind talk about the reversibility of the universe, and its progress. And this is one of those points where you can find, it's not reversible. Not with elastic objects, hard objects hitting hard objects. There is no elasticity. There's no going backwards, because the simple function is I can have a simple event take place where an object going, say, 16 miles an hour hits two objects that aren't moving, the same mass, and the theory would be is one will leave at 8 and the other one will leave at 8. Okay. And why would that? Well, I'll explain the reason for that. But you could sort of see how there's no way to reverse that. You can't have two 8-mile-an-hour things create a 16. All right, and the simple argument is that's because, well, let's see what happens when something hits something. So you have something going 16, and it rolls into something going 8. What it's doing is it's transferring its energy, okay, when it hits. Not going anything. So when the 16 hits something, we have to make it a smaller mass. Yeah, okay. So the 16 hits something. So this weighs 16 and this weighs 8, and this has let's just say it had a velocity of 10. Just make up anything, doesn't really matter. 10v. All right. So the 16 is going to hit the 8 and transfer its energy. So this one's the one moving, and hits the lighter object. It can't do the transfer. It can't do, I'm going to give you all my momentum. Because what's going to happen to the 8 is as it's transferring, this thing's already starting to speed up, right? And this one is slowing down. So for every one that goes in, this goes down to 15, right? This goes down up to 1, okay? And then this one goes down to 14, and this one goes up to 2. And this one goes down to 13, and this one goes up to 3. This one goes, so you can see that by the time when it gets to 8, what's going to happen is this one's already got 8, right? So half the energy's now been transferred. This thing's down to 8. But the key is that at 8 miles an hour, it's moving as fast as this is. So this is now only going to be going, the 8 miles an hour, and this is going to be going 8 miles an hour plus a little tiny extra. And you can see that now it's not going to be in contact anymore. So as soon as it gets to the same speed that this is going, right, the arrow's the same size, this starts to leave. And so this one's just going to keep rolling at 8. So it's going to give this one the 8, and then it's going to not have any more left, and that's going to be the end of the adventure. It can't transfer all the energy, because the lighter object will acquire the speed faster. Let's see if that's the right way to say that. See, if they're the same size object, it can do the transfer more efficiently, and it can actually take all of this arrow and put it in all of this, because the speeds are the same. The speed of sound, let's say, or the distance inside the object, or the mass of the object, is going to decide how efficiently the energy can go in. So when they have the same density, you could argue, then you can do the transfer. But if they're of different size, they can't. And so the faster thing can't make this go fast. It can't say to it, well, you're lighter, I'll give you all of my momentum and you'll leave at 32, right? Well, at 16, it was 8 miles an hour. This was going 8. Well, it's 10 here, so I'm really screwing this up a little. But you should be able to follow along. I can't give it the full momentum in the sense that I can't make something leave faster. So for elastic interactions, it's just not possible because the object is going to leave before I've finished giving it the energy. And so that's something Descartes noticed, and so there's, they didn't have good theory, and I'm still not giving you the good theory, exactly how the energy is transferred, but it was already observed that there is a subtlety between this perfect same mass circumstance and the circumstance where you give preposterous difference, like one thing's going 100 miles an hour and one thing's going 1 mile an hour and they're going in the same direction. This one's going this way and this one's going up against it, sorry. You don't get any of that 1 mile an hour that way. It's all converted into energy that way. And the idea would be is they split the energy. Now, the funny, kind of ironic, is that Leibniz, the guy who promoted this crap, his argument was so silly in the sense that he said, well, this formula doesn't work, if I follow Descartes' logic. Well, yeah, that's because Descartes' logic is based on this formula, so of course, why should it work for your idiotic formula? The whole point is that your formula doesn't work. And so it was kind of funny that, they were using this, pretty bad argument to defend that nonsense. So anyway, all right, so I didn't do a perfect job of that, but it's close enough, I think. For the people who really give a shit. So the argument I'm going to explain is here you have the bowling ball, okay, and you have a 16-pound ball, and you have an 8-pound ball. And the simple argument is that, okay, they have inverse velocity. So this is going 16, this is going 8 miles per hour, okay. So you get the idea. It's just inverted. The two numbers are inverted, which means it can't make any difference. They have the same momentum. Obviously, by this formula, they have a very different energy, because this one thinks the velocity is much more important than the mass. The mass is half, and the velocity is squared. So they start to hit pins, and what's going to happen when they hit pins, right? Well, the same argument is sort of this one has the higher velocity, okay? So when it hits the pin's going to leave with that higher velocity. So when the first pin this hits, it's going to impart a high velocity. We have to understand the pin might weigh 2 pounds, right? So I've taken 2 pounds and made it go the same 16 miles an hour. All right, so I've hit the pin goes off at 16 miles an hour because I'm going fast enough to make 16 miles an hour. Or let's say, well, for the sake of argument, 14. Can't quite get all the energy into it. But we know that when it did that, it lost its momentum. Its momentum was transferred to the pin. So it hits a pin and it loses that much worth of its momentum. So the 14 times 2, or 28 joules or whatever, it lost in the process of hitting the first pin. And so now its momentum is reducing. So its velocity has to reduce, proportional to how much energy it gave away. So its velocity now might only be 13. And so it hits the next pin and does the same thing, and that pin goes off at 13. Well, it'll be less, let's say 12. And, now this one's momentum, it's, if you total it all up, it might be down to 10 or 8. Okay, so, and now it can only give off 8 miles an hour. It can only make a pin go 8 miles an hour. And so you just do this process of subtracting how many joules you gave away to objects. So this is just like friction or anything else. You're just figuring out how much energy did I hit into. If I hit some lump in the surface, I'm going to impart energy into the surface. I'm going to have to lose it. So momentum is conserved, but obviously you can you can impose it on other things besides the objects you want to give your momentum to, and all of it has to come out of your momentum. So if two trains collide, if there's a train and it collides with another train, okay, they both weigh 5 tons, let's say, and now they're both going to go in this direction. So this one, they was going 10 miles an hour, and now when they're combined, it's going to go away at 5. So it's going to be a 10-ton train going 5 miles an hour, where it was a 5-ton train going 10 miles an hour. All right. These two trains have the same momentum, and if you're going to lose any energy, like as you're going to make sounds, and you're going to make sparks, and you're going to do all kinds of other disruptive things, well, then this can't leave at 5. It has to leave at some slower speed, because you did lose some momentum. You did hit some pins. You did transfer energy to the environment. All right. And that would have to come out of your momentum. Now, they use their magic theory, they say they lost half the energy. Half the energy is gone. So when I bang the two trains into each other, they're saying half the energy, which is a tremendous amount of energy, disappeared into the environment. Now, we'll never show you that, but anyway. So it just doesn't, see, and there's different ways I can cause this to happen, as I've shown. You can just drop a weight into one of them and make the transfer very minor. So you can make the transfer very subtle, very undisturbing to the train. I could throw baseballs into it. I could just throw, lots of ways to make it increase its mass without disrupting it much. And the simple logical argument is that you'll maintain the momentum. Most of it will be transferred successfully, and you'll have very little losses to the environment, and this formula works. This one completely fails. All right, so the opposite example would be the 16-pound ball, okay, going 8 miles an hour, can only give 8 miles an hour to a pin, but clearly loses so much less because its mass is so high, so it just loses a tiny bit of its momentum. In a sense, it's the percentage of its momentum. So it can hit more pins and make this one go 7, and the next one go 6, and the next one go 5. So where this one rapidly declines, the energy's used up quickly. This one, the energy is not used up quickly, and it can plow into more pins and cause more movement of those pins. And so the total amount of pins moving, that is, if you add up all the speed of the pins hit for these two objects, it'll be exactly the same. So if I take all the speeds of every pin it hit and how fast the pin was going, the two will be equal. And that's, again, this is such well-established theory, not only intuitively, but well-established in terms of experiments, that, I shouldn't have to argue it. That there's no room for this to be correct. It's not getting correct answers. It's way the hell off. It's saying, this lighter ball has twice as much energy. Not it's not a little bit more. It's twice as more. They're saying the 8-pound ball, if I total up all the pins moving away, that I'll have twice as much velocity in those pins. The average, will be twice as high. So if I just averaged all the velocities of all the things I hit, they're saying the average is going to be twice as much as the average for the 16-pound ball, which is just nonsense. I mean, it's just too silly. And again, this goes against all your intuitions about asteroids hitting the ground and stuff. I mean, they're basically telling you something that's just so silly, in the sense that they're telling you that if I take a little tiny micro style asteroid, and I make its mass very small, a 1, and I have another asteroid whose mass is 100, that somehow this one, going 500 miles an hour, okay, against this, giant one going 50, let's make it more dramatic, going 10, they're saying this thing has more energy, a lot more energy, because of this velocity, because the velocity is squared, so it's got this huge bias for velocity, and it just doesn't pay any attention to the fact of how important mass is. And mass is important. When you drop things, how heavy they are makes a big difference in how they hit the ground. And it's just silly, frankly, to think velocity is twice as important as mass. All right, so, but again, this kind of gets to some of their other nonsense. I have to do some more research on their reversibility theories, that you could reverse. See, obviously, you just can't reverse. You can't plow 2 5-mile-an-hour things into something and make it go away at 10. Because one of the objects is always, there's just no way, right? You think if you hit one of them with the 5-mile-an-hour object, well, then, of course, the thing's going 5 miles an hour. It can't possibly hit it, from the other one can't catch up to it. It doesn't have enough velocity. So it's already leaving at 5 miles an hour. This 5-mile-an-hour thing can't catch it. So it can't give it its energy, kind of obviously. And if you understand that they leak their energy in, that is, they kind of pour it in, okay, if the object starts moving away before they finish pouring, there's no way to continue pouring. If you're slowing down while it's speeding up, as soon as it gets to a little bit more than the same speed as you, you're not connected anymore. You can't pour more energy in. So it's completely a one-way system in terms of which way energy can transfer. There's no choices. All right, I'm back. I think I'll draw a little bit more. So in theory, like I said, in the 1700s, they really hadn't gone through all this. The 1600s, the late 1600s were, where this started as a controversy. And, they really didn't understand, all of the mechanisms. And like I said, we still don't have good theory of it, regarding how energy is transferred between objects when they hit each other. Okay, like what makes the energy go from one thing to the other thing. And I guess what I'm arguing is in the ideal state, when the two objects have the same mass, so if the masses are the same, is when the transfer is the longest. That is, they spend the longest period of time connected to each other. And the more disproportionate, okay, the masses are the velocities, the more disproportionate will be the amount of time. So when a small object is hitting a big object, or when a big object is hitting a small object, the problem is how long they're able to stay connected. Because the obvious thing you could argue is that the inertia of this small object is always going to be a lot lower. Its resistance to the change, its ability to change. Little things can change quickly. Big things change slowly. So that inequity, slow to change versus fast to change, is always going to mess up the ability for the transfer to take place. So the little object will often reflect off the heavy object because it's the little object's able to change so fast that it changes, not only gives its momentum, but it gets its momentum right back again from a reflection. Because it can change so quick, and that happens fast. And the same, you could make similar arguments about what happens in the exchange of the big object to the small object. The small object will gain the velocity so quickly that it leaves before this object can impose any more. So in this case, the big object against the little object leaves at the same velocity so quickly that this object can't pour in more energy. And in the case of small object against big object, it's going, the small object is going so fast compared to the big object that it is going to reflect before the big object starts absorbing. Yeah. But you could sort of argue the absorption has to be all, like the 1 mile an hour, all of them have to have 1 mile an hour. Then all of them have to get 2 miles an hour, every electron. Then all of them have to get 3 miles an hour. So the idea is that, it has to be imparted on all of this mass, and that takes time. And there isn't enough time. The velocity of the small object is just too high to allow for the time necessary for that complete transfer. Yeah. So, that's a little more complex argument, I'll concede, but the smart ones, will get it. Alright, so now we'll just do the stupid comments. I mean, I've been over this so many times in so many ways, and you get these moronic comments that don't deal with the fundamental facts. So let's understand. The fundamental fact is there's two formulas. They have completely different descriptions of a thing called energy. It's a real thing. Newton didn't think, what was it called? The quality of motion is what the word was used for this idea of momentum. Okay, so they didn't call it momentum, they call it quality of motion. But they clearly believed, clearly asserted, clearly in all of Newton's mechanics, he's clearly measuring velocity and mass. Those are the key ingredients, and he's clearly seeing them as being why things move through the space the way they move. So there's just no doubt about it. Every kind of way, Newton saw it as energy. And in every kind of way, Descartes was talking about energy. So they're talking about exactly the same thing, and they have two fundamentally different formulas. They create two fundamentally different universes. If you used 1/2 mv squared, I would argue you won't get where planets are going right at all. You get all the wrong answers. It doesn't work. It only works in circumstances where you have these equal kind of proportions, or in circumstances where you have given everything this wrong energy. So if you give everything in the universe the wrong energy values, you can probably make it work, theoretically. But it won't. You'll find the flaws soon enough. You'll find the bowling ball, wrecking ball, two trains things. You'll find soon enough where it doesn't work. You just, in navigating your rocket ship, you'll find it. Okay, because you'll be wrong about how much energy it's going to take to move it. All right. So Piro says, no one is saying the lighter arrow has more energy than at the same speed as the heavy arrow. So again, this is so off the subject. That's not the argument. The argument is the heavy arrow going half the speed, or the light arrow going twice as fast. Okay, half the speed, half the mass, twice the mass, or twice the speed and half the mass. Talking about those ratios, the two formulas get completely different answers. One of them, the momentum says the object hasn't substantially changed in the sense that its momentum is the same, and your theory is that one of them has twice as much energy. It's a completely different answer to the simple question. So this whole pretending there's no controversy, no conflict, no problem is just a nonsense. You have to choose one of these theories. You have to choose that you believe in momentum, or you have to choose that you believe in kinetic energy, but you can't believe in both because they get contradictory answers. That's the simple argument. You want to say that's not the argument, then you're denying the history, you're irrational, frankly. You're just frickin' irrational. There's no compatibility between the two formulas. They make overtly discrepanary statements about the facts. One says it's 2 feet long, one says it's a foot long. That's a huge difference, and there's no way to weasel out of it. You have to choose. You either go with Newton and Descartes, or you go with Leibniz, who didn't do any experiments really, and just kind of made the whole thing up. All right. We're saying the higher velocity can give any object more energy than another. And, you're just like, duh. No one's arguing that you give something higher velocity, it's going to have more energy or more momentum. Of course it is. That has nothing to do with this subject. All right, anyway, a light arrow can have more energy if it's going fast enough. I mean, it just doesn't make any sense. Does it have more energy than an arrow going 1/2 the velocity that weighs twice as much? Does it have more energy than that arrow? Just the evasion over and over again. So many videos, illustrating these thought experiments over and over again. I've overtly asked him, when you go bowling, do you go run for the smallest ball you can find in the bowling alley because you think it has 4 times as much energy? That's what physics says right now. So that's just absolute babble. It has nothing to do with this subject. It has nothing to do with what physics says. Physics says silly things. That, again, I could show you these experiments. That somehow I have 2 trains, going down the track. a little train, a little toy train. It's going down a track, and I drop twice the mass in it. So now I'm going to double its mass just by dropping it into the train as it's moving. And it's a proven fact that it loses half its velocity when you make it twice as massive. I mean, it's a proven fact. And you're saying somehow it lost half its energy in that process. Somehow half the energy disappeared into the environment, presumably unrestorable. Yet you must also know that if I just bang that train into a spring, it will compress the spring exactly the same amount as the spring that launched the first train. That the energy's still all there. That none of it, no significant amount of it disappeared. Maybe 1% in the transfer. You lost 1% to the environment. That's it. The rest of it you can fully recover. You don't have a single experiment done in the history of mankind to demonstrate that a 10-ton train going 5 miles an hour has half as much capacity to create energy as a 5-ton train going 10 miles an hour. You don't have a single analogous experiment to that experiment demonstrating where you lit more light bulbs with the faster object. The faster object, your formula always says, has more energy. That's the subject. All right, so I basically said that kind of stuff in my response, so I don't know if it's worth reading my response, but let's see. And this isn't the assertion being made. I go again with the 10-ton train analogy. He just keeps ignoring the real thought experiments that have something to do with the subject, and he just keeps drifting off into bullshit. All right, so Piro. I left the half out because it's not important. It can be changed with units because it's a constant, and you are so confused. I'm confused because he just overtly did what the past says is okay, in the sense that Leibniz's original formula was VMV. Okay, there was no half, so it was that much off. It was a full half, that is 100% off. It was a preposterous exaggeration versus a ludicrous one, or ludicrous versus preposterous, right? It wasn't just wrong, it was incredibly wrong. And you drew, again, this formula in that state, and you're saying nobody should react to that fact. That, at least have the courtesy of putting the silly half in and making your ludicrous statement just preposterous. Please. Anyway, I'm simplifying as much as possible. So you could just say the kinetic energy formula, right? Or we could just say KEF versus mho, and simplify the conversation. But anyway. Meanwhile, you said gravity in ms, meters per second, the other day, and it's meters per second squared. Well, again, I didn't say that, frankly, in any contextual way. No one would think I said any such thing. So I've done it over and over again. How many times have I done the rain analogy? How many times have I drawn the arrows of gravity constantly coming down and filling up buckets and all of those analogies? I clearly don't misunderstand the subject. All we have from you are these silly comments. So how can we glean what your understanding is? You don't make any videos, you don't do any physics explaining anything, so we don't have any context for your statements except your silly bullshit comments. So the fact that you can't get my context right, even though I've done, hundreds or thousands of hours worth of videos, is bullshit on you. Okay. You are seriously confused. No, you're seriously incapable of staying on the subject. The subject is Leibniz was a religious kook who really was putting the metaphysics into the physics. It's all in his own writing, even, how this was the important aspect of his physics, is its validation of his religious visions. This is not a good history. Leibniz died a nobody, let's understand, so his arguments on their face, by themselves, didn't mean much to anybody because nobody liked him when he died. And that this whole thing was just reinvented again, 30 years later after his death. The argument was again reinitiated, okay, in an atmosphere, again, where this is all about nationalism, the French and the Germans against the English, blah, 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 blah. And has this famous woman in the middle of this whole slop, a tiny bit of experimental evidence, and just a bunch of mushy talk, okay, separated from having to make this real argument. It was just a bunch of speculation. It's like doing a trial, with no evidence. We all just show each other pictures of criminals and say who was a real criminal and who was innocent. And we just speculate based on what they look like. I mean, it was a horrible examination of the truth. It really has no integrity. All right, should be back. All right, so I'll reread the last sentence again. You're seriously confused and need to find a nice place to take walks or something. So this patronizing garbage. I mean, just putrid. Alright, so I said to his first pile of crap, amazing, silly excuse making, kind of evidence about how you math types don't take actual precision very seriously. I mean, they do. They just throw these quantities all over the place, Gremlins, 3 gremlins equals 6 hobgoblins, and therefore 1 pixie equals 7, Tinkerbells. I mean, it's just, bullshit physics. Anyway. And then I said, you still haven't answered direct questions previously asked. And so I reposted the previous thing. Do you use an 8-pound bowling ball? Is that because it has twice as much energy and you want to take advantage of that twice as much energy? Meanwhile, you said gravity was in ms, so I said gravity causes velocity. Velocity is just meters per second. So at any one point, it has a velocity. Obviously, as it moves through space, being pushed by the gravity, at every 1 second, it has a velocity. It's a certain velocity at every point. It's going faster and faster and faster, but at any one point, it has a specific velocity. Okay, there's just no doubt about that. It's going 30 miles an hour, and then it's going 60, and then it's going 90. So there's nothing, there's no obligation to talk about its velocity as if I'm talking about some average velocity or some other thing. I can simply describe the fact that it gains velocity as it travels, and when it hits the ground, it's going to have a velocity, a final velocity. It's not going to have an it's not going to have an ms squared. It's going to have just meters per second. All right. So then he says about the confused thing, and I said, you are seriously stupid and need to quit licking your dog's ass. I thought it was appropriate. So anyway, then this stupid Anarchy guy chimes in and says he's deleted his previous comment because it was just rude shit. And so I said, you're a jerk. First off, we don't even have an exact quote from Piero, just out of context claim. Why don't you find the time code for the egregious error I made in describing gravity? You seem to be the people incapable of realizing gravity as a constant force. I should have said a continuous force. Where the train rolling down the track, so he takes rolling down the track to mean going downhill. So, I mean, even though I've drawn it so many times, this is about trains going downhill, has a constant momentum. You just make assertions and provide no evidence. You say a 5-ton train, so I give him again the perfect analogy. Going 10 miles an hour has twice as much energy as a 10-ton train going 5 miles an hour. And again, logically, you can just understand that if I put a generator on the wheels of those trains, you know that the generator has torque, and that the heavy train is going to keep rolling while the generator's turning, and the 5-ton train is going to run out of steam. It's going to, it's going to have its energy is going to be absorbed much quicker. Its velocity will be absorbed at a much faster rate than the velocity of the heavier train, and in the end, they'll turn the generator just as many turns. Well, just as many turns based on speed. So again, it's, how fast you turn the generator increases the torque and increases the amount of energy being pulled out. So obviously, initially, the fast train is going to spin the generator very fast, but it's going to run out of spins quicker than the heavy train that will spin the generator slower, but more turns. Okay.
they're going to light the same number of light bulbs. Their theory is the light train lights twice as many. They don't have a single experiment in the history of mankind ever collecting that extra energy. Nowhere, ever, 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 ever was it collected. Okay, why can't you show me any evidence? Why can't you show me a single experiment demonstrating two things of equal momentum producing different VMV energies? So that's the simplest argument you can make. Just take any two things of the same momentum, a bullet and a bowling ball. Okay, an 8-mile-an-hour bowling ball versus a 300 meter per second bullet, and show me, okay, that those two things of equal momentum, one of them has 100 times more energy. Show me you collecting the extra energy. All right. Let's see. Now I just point out, if you can't do that, I'll just block you. Yeah, so if you can't show me the evidence, then just forget it. Okay? Because I'm not going to just be constantly lied to. Well, anyway, delete that comment, so I can't remember the other part in it. So here, I still have the crap he wrote. Gravity causes velocity. Velocity is just meters per second. So he says, if I throw a ball upward, gravity will slow down the ball, not speed it up. So again, anybody who's watched my videos knows I've never asserted that you throw something into gravity and it goes faster. Ever, ever, ever. How do you fail to see such obvious flaws in your reasoning? So again, there's no such flaw in my reasoning. I've never said any such thing. It's just an absolute lie. And why should I have to keep responding to your lies? Anyway, Piro is obviously correct in that gravity causes a change in velocity. Again, and never have I said anything other than that. It's just a despicable lying. Ugh. Anyway. So I respond to this stuff with, this isn't just a straw man, it's a lie, man. You certainly have no quote of me asserting that opposing gravity speeds things up. Yours is the reasoning that's absolutely ridiculous. Again, show me some experimental evidence of your ludicrous claim that objects with the same momentum but different masses and velocities have different energies. So just show me one experiment where things with the same mathematical momentum you actually collect different energy from them. Show me one experiment, just one, and you win. But you won't show me that one experiment. All right, more silly lies that I have ever seriously asserted that gravity is something other than a continuous force causing a continuous change in momentum. As momentum is the subject, my argument is that objects pushed by the same force into gravity will return to exactly the same force when they started with. So you shoot them up with a force and they land with the same force, and they never have any extra energy, okay, while they're traveling. You're asserting that if I shoot a light object into the air with the same exact force I shoot a heavy object, that somehow the light object has twice as much energy. That's your assertion, even though it comes back and compresses the spring exactly the same amount as the other spring, even though it returns with exactly the same energy it started with, that somehow while it was flying it had more energy. Well, why don't you prove it with something, some piece of evidence? Gravity gives back what it takes. Your silly theory states that the same force can give lighter objects more energy. Again, you can provide not a single shred of experimental evidence supporting the kinetic energy formula. So then he says, more so, in a previous post you said, so then he takes two statements and smashes them together. Okay. Where I said, you seem to be people incapable of realizing that gravity is a constant force. Obviously, I meant continuous. The train rolling down the track has a constant momentum. So clearly just stating that there's no force acting on the train. It relies on its own momentum. So I had pointed out that they're two different statements, okay, and I made them clearer. Gravity is a constant force applied continuously. I have repeatedly stated it is like rain continually falling. The longer you're in it, the more mass you have, the more of it hits you. So, I mean, I've made that clear. Everybody's watched these videos, known I've done the rain analogy a dozen times at least. Anyway, trains rolling down the track are not pushed by constant force. There is no constant source of energy. Therefore, the momentum is constant until they encounter a pushing or a stopping force. Anyway, so, and then I give them a fair warning. So, I'm not going to keep responding to false, out-of-context claims regarding what I have said. I have made repeated assertions in my videos. If you can't respond to those repeatedly made assertions, then I won't respond to you. And then he just does it again. Here it is. Wait, are you actually going to say that a train rolling down a track isn't going to speed up? So again, clearly all the examples, the trains were on a nice flat plane. There's nobody arguing about trains going downhill. So goodbye. You're just full of shit. You're just a time waster. Ugh. I mean, if you're not going to watch my videos, then don't comment. That should be the simple argument to make, okay? If you can't watch, and you have to watch almost none of them, not to have heard the rain analogy, not to seen the nice flat track that the trains are moving on, not to have heard all of that and seen all of that, okay? Again, you idiots want to sit there and make arguments in text. You're the ones that have the higher responsibility. I've made lots of comments, and they're in context, and they have been stated in context, and where I've explained the context. You don't explain your context, so you're the ones that have the liability. But realistically, there's no point. If you're not going to make videos, and you're just going to make snide comments out of context and not pay any attention to what's been repeatedly stated in the videos, I have no obligation to interact with you. Okay? It's just not going to work. You're gutless cowards, and that includes Piro. Why doesn't he make a video? If he knows this is the right answer, why doesn't he explain how it's the right answer? Why doesn't he explain how momentum is wrong and kinetic energy is right? But he won't. He won't come close because he knows he's going to fall into a quicksand he won't be able to get out of. Because he doesn't know the history, he doesn't understand the concepts at all, and he just wants to believe that physics can't be stupid. But it is. You've chosen badly. Your totem poles. So I think I already did this. No one is saying later, and this isn't assertion being made. Again, you're not even close to the subject. I pointed out the 10-ton train analogy. So he just keeps evading this subject, just keeps evading it, 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 evading. Did I start at the top and go down, or which way did I do this? Well, it's probably enough anyway. You can get the idea. Piro's arguments are insipid. Yeah, I think I started at the top, right? No, I don't remember this one. When I said shape does not define energy, if you notice, I said it in classical in physics. So I pointed out how, there's no such thing. There's no such thing as classical or unclassical physics. There's just accurate and inaccurate statements. And you can see that from the past. I mean, it's ironic that Leibniz was also a believer in this most efficient, what did Feynman call that? Not the shortest path, the least action. So the least action theory that they pretend is kind of modern. Leibniz was already talking about that in Huygens, back in the 1600s. So it's kind of funny because they thought that was a real thing, like God was somehow directing things so they would go on that least action path. They'd always take the shortest path. And it wouldn't just be that that's the only one you see. Is this the path? There's a path that works, and all the other paths, frankly, just don't work. It doesn't happen. But we're assuming they do happen, even though they don't happen. There's just no evidence of them happening. All right. Anyway, you claim we are arguing. Well, I might as well read some of this. Okay. There's just accurate. The kinetic energy formula is silly and nonsensical. And it has been clearly shown you cannot produce one piece of experimental evidence to support it. So again, they won't show a single experiment showing the more energy of the twice as heavy, twice as light, twice as fast object. So you claim we're arguing shape changes energy. You are wrong. That's a lie. I responded to a specific comment that brought up the subject of shape. So again, this shape doesn't have anything to do with the fundamental arguments. That was obviously part of the ballistics argument, that you, quite frankly, quite obviously, you can shape a bullet and it makes a difference. I'd say lying if I thought you understood well enough to lie about it. So I'd like to say you're just an ignorant dupe, but lying religious zealot is where the facts point. Okay, and obviously, there's no arguing this in some sort of disciplined manner because Piro can't stay on the subject. He can't make a single assertion that he can back up that has anything to do with the subject. All he can do is lie about what I've said, lie about what I've argued. And he doesn't disprove any of it. He doesn't cite any evidence, any experiments ever. Hey Gary, I didn't say the M1 object leaves with more energy. So this is overtly what the formula says. So what's the point, right? I didn't say it, but yes, of course all the other physicists are saying it. Okay, it leaves with exactly the same energy. Again, what even context could this be in? The formulas clearly are conflicting, so that can't be denied, and yet he's still denying it. But more momentum. So somehow you can make more momentum. See, this is the same argument that was happening before, right? They try to break momentum and say now you can make free momentum. The conflict in these two formulas means one of them is a free energy formula. If one of them is right, the other one is a free energy formula. That's the clear implication. You can't avoid it. So that proves one of them has to be wrong. All right. Please at least understand the claim. You're the one not understanding the claim. Again, he's just pretending that because the science historians say this controversy didn't matter, it wasn't important. It's not about anything real. It's just semantics. This isn't about semantics. It's about a clear definition and a clearly different answers. 500 watts, 1,000 watts. Those are not compatible answers. You think momentum is energy. So did Newton. So did Descartes. So did a lot of great scientists. But mv is not the same as mv squared. Yes, obviously it's not the same. Whatever you call them. That's the whole point. Your theory's wrong. Their theory's right. Newton was right and you're wrong. All right. Hey, Gary, I didn't say M1 object. Okay, so and I said the implications is the formula of the form. I should have said of, not is. The formula are obvious and have been clearly illustrated numerous times. In numerous replies, I have pointed them out to you. Show me one experiment where you show a bullet lighting more lights than a slower object with equal momentum. So just take any object of any size and speed that comes up with the same momentum number as a bullet, and then show how the bullet makes more lights, makes more energy, makes more heat, makes more anything. Show one experiment where you collected that extra energy. And you can't show it because it doesn't happen. All right, leaves with exactly the same energy. 8-pound bowling ball going 16 miles an hour, 16-pound bowling ball going 8 miles an hour. You say the 8-pound ball has twice as much energy. Show me any experiment demonstrating anything close. And clearly what I can show you is professional bowlers all using 16-pound balls, which doesn't make much sense if they could have twice as much pin knocking down power if they would just go lighter. Even to 10 pounds, they'll gain so much more power. 12 pounds, so much more power. Should have gone the other way. 14 pounds, more power. 12 pounds, even more power. 10 pounds, even more power. That's your theory. It's a pile of shit. Okay. Police at least understand the claim. So, it's just so... It's just... This is, like I said, this is the realm of just ludicrous, right? Like, this is literally insane that you have to have an argument with somebody who is telling you to understand the claim when they're ignoring the overt claim. The two formulas get completely different explicit answers. How is that duality sensible? 2 plus 2 equals 3. 2 plus 2 equals 4. They're two different answers. You're saying I don't have to choose one of those. I can believe in both of them. I'm saying, no, that's insane. It's not physics. That's some other thing. That's religion. Newton, Descartes, and many other scientists also thought so. Fact is, they had good evidence and good reason to believe. You have neither. There's no good history here. There's no good experiments here. This whole thing was a tragic mistake in the history of science. Science ought to just man up and say, whoa, we really took a wrong turn with that nonsense. We had a perfectly good theorem of energy, and we ruined it for absolutely no good reason. But MV is not the same as MV squared, whatever you call them. I don't even know what that even means. I mean, clearly I'm the one making that argument. You can't have both. You have to choose one of them. And if you're going to choose your stupid kinetic energy formula, you're going to be choosing badly, because there isn't any evidence supporting it. You're clearly ignorant of the history, ignorant of the facts, ignorant of the experiments. Your 1/2 mv squared is just religious gibberish, and it has no scientific veracity. All right. Okay, now I think we're done. Just horrible. So I wish Bureau would make a video. It would just be really good entertainment, frankly. Countering, arguing anything. Like even play 5 minutes of any of my videos. Well, not any. One of the videos in this series anyway. Or just write the assertions down, quote them accurately, and explain how theoretically you can make sense out of the idea that the 5-ton train going 10 miles an hour has twice as much energy, that is, twice as much capacity to turn a generator, as the 10-ton train going 5 miles an hour. Just show how that possibly makes sense. It won't do it. So, because he can't do it. It's a simple answer. He'll never be able to do it. No experiment demonstrates it. I guess that I will just have to show the simple little train, where they drop the weight into it and they measure its velocity, and it's just about half of the original velocity. So you double the mass, you have the velocity, and again, my clear argument is going to be you won't see any evidence of half the energy disappearing somewhere. All you'll see is a little degrade in the velocity that accounts for the little bit of friction you created on the track, and that's all there's going to be that you have to account for. And there's no reason. Like I said, I wish we could find the experiment where they just take the two objects and crash them into the same spring. Just take the 10-ton train going 5 miles an hour, and then the 5-ton train going 10 miles an hour, or just 10 feet for, just little trains. You don't got to use big trains. And just show them compressing the spring more. That's all. But we don't have that experiment. I showed the experiment where they have a one-mass train and a one-mass train, and then they compress the spring and release them, and they go away at the same speed, and then you put a 2-mass train on one side and a 1-mass train on the other side, and the 1-mass train goes exactly the same speed away, and obviously the 2-mass train now goes half the speed of the original. So the momentum is completely conserved. That is, there's the same amount of total, okay, and all you've done is demonstrate that obviously the 2-mass train going half the speed has exactly as much energy as the one-mass train going twice as fast. And so I showed it already. It's a done deal. There's no room for this stupid formula. It doesn't work. It doesn't get correct answers. Yeah, whatever. So we'll call it a video. And but like I said, there are important aspects to this subject in the sense of this is now implicating other notions of physics, because they've never really thought about any of this stuff. They don't model any of it. They've never tried to model these interactions with actual physical models to kind of say what happens at second 1, what happens at second 2, 3, 4, to understand even the simple argument that obviously fast thing, when it hits a big thing, it's just not going to be connected to the thing it's imparting velocity on long enough Once it starts leaving at the same speed this thing was going, so it has to be big thing hitting small thing. Once the small thing is going the same speed as the big thing, it can't give it energy anymore. Those simple arguments that it's just not reversible. Slow things can't make fast velocity. They can't. Unless there's a circumstance where they're hitting a lever or hitting some other mechanism to make it happen. So without some other system, just on their own, these elastic objects can't, they just can't. Slow things can't make fast things. Small things won't fly off of big things at twice the velocity, the way if they could get all the momentum. So they can't collect all the momentum. So if you use the Newton's cradle and you put a small ball at the end, the small ball at the end can't, if you take the big ball and hit and you have a small ball here, the small ball can't absorb all the momentum. It can only go away at the same speed that this one was traveling, and it has to move the second ball. So the second ball has to carry the rest of the momentum, the other half of the momentum. They haven't charted any of this stuff rationally. And if they did it rationally, they'd see that there's no room for this extra energy. Alright, so this has been a DraftScience video presentation and such. Until the next time and whatnot. Yeah.